Hey, welcome to Engineer's Workshop. It's a really cold day here in Virginia. It's about 28, 29 degrees outside. And so what it is outside, it is inside, because as you can see, we're kind of wide open to the elements here. You work with what you got, but this building is not enclosed and far from being enclosed. Time and money, time and money. So I got an interesting project today. How often is it that you get to do a machining project for your wife? Well, that's exactly what I've got here. I have to machine a brass adapter bushing, I'm going to call it. It's wedge shaped. It's got like an 11-degree angle to it to go between a tub overflow tube and the back wall of the clawfoot tub itself. Let's just, I'll cut over to the, I made a model, of course, in SolidWorks. So let me show you that, and then I'll show you the setup that we're going to use to do this on the K&T. I'm probably going to work inside the little foil bubble hut to kind of trap some heat in, because it is super cold. My hands are going to be going numb here quickly, but let me show you what we're going to be doing, and we'll get straight to the machining. We put in a new clawfoot tub when we redid our upstairs bath. In the new tubs, when you compare them to the old, 100-year-old clawfoots, the back plane of the tub is very sloped compared to the standard one. And as you can see, that the overflow drain, the angle on the overflow drain doesn't match the new tub. If we were putting this up against the old tub, I think it would be about perfect. Now they make these wedge-shaped washers, but even with that, it's compressed a lot up at the top, and it's basically loose at the bottom, so it's not sealing. To get it to even seal a little bit, this is cocked back from a true vertical, probably 3 or 4 degrees, which bothers me. So I want to get, these pipes and this line sitting vertically again. And to do that, I've got to make a wedge-shaped brass piece. It's kind of like an extension to sandwich between the tub and the overflow. And I got to get that angle, the relative angle of those two surfaces, pretty much exact, so that I can use a thin gasket in between and get a good seal. So I'm going to be taking some measurements and come up with the angle that that little wedge-shaped brass piece needs to be. Okay, we have a slightly oval hole in the tub. It's 2 inches wide by 1 7/8 tall. And we have to get the angle of that back face of the tub relative to vertical. I'm going to use a combination of my protractor and a Starrett level, which has bubbles on both horizontal and vertical axes to estimate the angle from vertical. Okay, here's the crazy setup I used to determine the angle of the back of the tub relative to vertical. I used both hands, and I was able to tighten the adjusting screws on the protractor using the level as a reference for the blade. And I got a result, if I could zoom in here, of 16 degrees, which is more than I thought it was. So the angle of the discharge pipe is no more than a couple degrees. I'm going to take this down and measure it a different way, but then the difference between those two is the angle of taper of the wedge that needs to go between these. Using my perfectly level kitchen island as a reference, it is level because I built it that way. We have a little indexing pilot here. It's 2.234 by about 43 thousandths deep. So our brass piece, I'm going to match this diameter, and I'm going to put the little pilot in this so that this will index together. I think I'll use an RTV or maybe a Loctite gasket sealant between those two. So what's our OD? 2.96. 2.96. And then we've got a flat here, but that doesn't matter. From my level reference, I've got this blocked up to where the flange is sitting flat. So I will set up the protractor and get a level surface again sitting on top of this and measure that angle of this face. There's our difference. And that looks like 4 degrees, maybe a hair more than 4 degrees. So the difference in the angle, what did I say the first one was? 16 and 4. So we've got a 12-degree angle we have to machine into the brass wedge. Okay, so here's our finished little brass adapter washer slash wedge. And the features I have on it on the back side, now this is the side that's going to mate up with the discharge tube. I've got a step milled into the ID. This is a 2-inch ID, and this step gives about, I don't know, 5 to 10 thousandths clearance over that stub sticking out of the tube. And the OD matches the OD of the tube itself. Now on the other side, I milled a series of concentric grooves. Now they're concentric in that they're about that, which is a perfect circle. Once you slice this thing on a, I think it's an 11-degree angle. I'll put that in the notes if it's any different. These are going to be slightly wonky looking relative to the ID, but not enough to notice really. And so this thing, let me show you what this looks like in cross section. So I've got these, and they're only 8 thousandths deep. These are made with an 1/8-inch ball end mill. And the purpose of these is to bite into the rubber, like it's a foam gasket that's going to go in between the tub and the brass piece here. And so they're going to bite into that gasket, give it a little bit more compression on the gasket. I think I'm going to use a Loctite 574 on this back surface and in here to permanently stop the gap between the discharge tube and the washer to make that leak proof. And then this gasket will take up any minor irregularities we have in the diameter, in the angle between these pieces. So that's what we're going to machine. It's going to be a challenge to hold it, but I've got some fixturing that I'm going to set up in order to do it, and let's get on to that now. I have a piece of material I bought from McMaster Carr. It's a 5/8 thick piece of brass. Expensive. This was like 60 bucks. I'm glad I got 5/8 because of the amount of taper in there. I'm going to be going from full thickness down to almost nothing. And to get the angle established, I bought one of these, bought the cheapest tilt table on the internet. This is a little made in China tilt table, 5x7 size. It works pretty well with, these are 5/16 carriage bolts as, you know, light duty means to clamp the brass to the table. I'm going to square this up, get it level with the travel of the table. It doesn't rock, you know. I'm sure the accuracy of this thing is not great, but you know, if I tram it across and get it reading 0 with an indicator, I'll be able to use the Starrett level and my bevel protractor here to get that 11-degree angle duplicated. I've got features on both sides that I have to work with. So the first thing I'm going to do is pop a couple of holes in the piece of brass, and I'm going to clamp it down diagonally opposite with a piece of Luan plywood in between. I got to cut that to size, and then that'll let me mill down without milling into my, you know, super expensive surface here. And you know, for what I got, until I can afford a better one, this will suit me. Saw is cold and sluggish this morning like me. Well, the actual model looked a little bit better than the drawing did, because for the model I had a static angle of 7 degrees built into it, but when I changed it and did the actual measurements, I had to update the drawing, and this thing almost comes to a knife edge. I have really only about 4/1000 thickness at the thin side. So what I'm going to have to do is probably cheat that 11.8 degree angle. I'll keep it closer to 11 degrees, 11.2 degrees, and make sure I don't run out of material there. I have features on both sides, so I'm going to be putting the 2-inch hole in first, then the counter bore. Then I will flip the part, and I'm going to put in a witness circle identifying the diameter, so that when I tilt it at the 11 degrees and change, and I start cleaning off that taper, I'll know when to stop. As soon as I come up against the high side, I'll be able to stop. Then I will put in the little 1/8" grooves. Then I think I have to square up the table again, and then begin to mill through and catch this piece so that I don't nick or mar the OD, because the OD is going to be a polished, finished, visible surface. So got to be careful, got to not use up and waste that expensive material, even though technically I do have twice as much. I could, do a second attempt at this if I screw up the first one, but I don't intend to screw up the first one because Christmas is coming. So let's get the setup going and get started on this. First operation, drill a couple of holes to mount it at diagonally opposite corners, and do this without drilling into my vise. I have one side that's a little bit better than the other, and I'm going to use that as the side that goes against the drain, because I don't want to fully machine the surface and take any thickness off of that. So this will sit just a bit wonky on the table, but not a big deal. And I'll leave myself enough room to indicate level at this end. That's with my knee all the way down. Now let's see about getting this clamped to the table. I don't know if you can see that. So we'll just eyeball that for the tilt table, and then we'll run an indicator on it. Okay, I'm clamped down. I am not tight at all on the actual table, and that is eyeballed with the bubble the same as I was getting on the rotary table. So let me snug that, and we'll tap it in from here. I'm going to use a parallel here so I don't have to hop over those T-slots. My first guess is within a couple thousandths over 4 or 5 inches. I'd say we're looking pretty good. Everything that I'm machining can be done with 3/8 shank tooling. So I've got a brand new ball end mill, and I've got a brand new, it's a 3-flute And for the next couple of clips, the audio for some reason didn't work. So what I'm basically doing here is trying to establish the center of the brass piece to where when I cut out the actual bushing that, I'm going to basically land entirely on the piece, because with that 7-degree angle, it does make it a little bit wonky. So I started out by milling the ID, which is a 2-inch ID, and then following up with all the features based on that as a reference. Okay, the next step is the counterbore in this to clear the spigot on the tub drain, and so that's 900 thousandths. So it's 9.9325. And we want a 60 thousandths depth of cut. So I'm going to bring this around. I'm going to bring the cutter down until we contact the workpiece. And I'm going to zero the quill. And I'll do this by hand elevating the knee. And to get a feel for this, I'm going to loosen the quill so I don't have any resistance. There, we're in contact. So actually I'm going to drop the knee 2 more thousandths and we'll be at 0 on the quill. Okay, so now it's a matter of dialing in 60 thousandths depth of cut. And I'll do that while the head is in motion. Okay, now it's time to flip the part over, zero it, actually tilt it and then zero it. Okay, logic would dictate that if I've trammed this table, this surface on a parallel, and it is perpendicular with cutter axis, then if I establish the 11, theoretically 11.8 degree, and like I said, I'm cheating that a bit. I'm cheating it down to about 11.2 degrees. See if you can see this. 11.2 degrees. That if I tram the surface of the blade and get that to 0, then that is the correct angle. So I have to loosen my trunnion. I guess I need to do this eyeballing the bubble on the level just like before, and that is pretty close. I'm going to have to change the way I clamp this because the nuts are running into the hold down dogs. Well, that's within a couple thousandths over 3 inches. So now the task is to offset the cutter. Actually, first task is to zero the cutter on that 2-inch cutout, which is going to be tricky. The Y looks pretty good. I think that's about as close as I'm going to get it. I can indicate a little better once I start cutting some of the high side off because it's so oblong facing the mill right now. I don't have a tremendous amount of clearance on that bolt head. I'm going to have to cut it short, but I can get started. So this is basically the technique, in and out and round until we come down to a finished thickness. As soon as I clean up all the way around the bore, I'll re-indicate. I trimmed off the bolts so we can proceed deeper. At this point, the entire hole from this side is all on one plane, so I can indicate it, but it's actually going to be an oval, so I'm going to have to split the differences on the X and the Y. Okay, I'm re-indicated, so I'm going to attempt to come down to the same depth and recut the OD. I'm going to call that a full cleanup. 1/8 inch ball end mill, 2 flute. Run this RPM on up there about 3,500. Okay, there are 4 specific diameters, and I measured to the center of the spindle for each of these. Starts out with 1.100 and then steps out another 100 thousandths for each groove. So I can just put the spindle directly on that number. And the thing I'm going to have to establish is when these this little cutter is in contact with the brass. The last cut cuts this part free, and the diameter is 2.967, I believe, 2.965. So I have the offset half of 2.965 equals 1.4825 plus the radius of the cutter, 0.1875, equals 1.670. That's going to cut inboard of this. Unfortunately, it is going to cut into this nut just a bit. I oriented the flat to minimize that, but I'm going to do that first, make sure that doesn't move, and then we'll just continue working our way down. And we'll go 50 thousandths at a time through the brass, and probably increase the speed. This is 1 RPM. That's a bit fast. I'm going to slow that down a hair. 3/4 RPM. Yeah, it's doing a full cleanup on that side, which is good. The visible side is going to be mostly this one over here. To cut all the way through this, I'm going to lose my clamping from the 2 bolts. So I've had to improvise a support. What I'm going to do is cut through, I guess, along the x-axis of the table, all but a little bit of a web here on the top and the bottom. And then I'm going to bridge it with this wooden clamp that's going to grab the underside of the tilt table and bear down on the 2 parts of the ring in the middle. And then I can come back and just swing those 2 little arcs and cut through it. So I'm going to plunge through and get into the wood I think I'm going to slow the head down to decrease the feed pressure. Okay, see if we can complete this cut without it moving. I think I'm just going to crank it by hand. Just kind of feeling lightly for any signs of movement. Once we go through, I still have to keep cleaning up for the radius of the cutter. Now I'm going to have to drop the knee to hop over this clamp. Back in contact with the wood. Tiny bit of witness lines on the edges. That's not a big deal. Let's take this over to the buffer. Clean it up. Well, I hope you enjoyed that. That certainly was different. There's some little striations from, going in and out of the cut, but I don't think those will polish out. I would have to literally like sand this and then, take it multiple grits and then go back to the polisher, but I'm going to lacquer it, and you're only going to see about that part of it, so it looks pretty decent, and I think it'll do the job for what we want it to. So thanks again for watching this Christmas present project on Engineers Workshop, and I hope everybody has a great holiday. Merry Christmas and a Happy New Year. And don't know if I'll get any videos out between now and the end of the year, but we'll have projects in the next year coming up for sure. So till then, everybody take care, stay safe.